Dear students, welcome to our science episodes. Today we are going to continue graduation of elements in the modern periodic table. Today we are going to discuss metals, nonmetals, and metalloids. Elements in the periodic table are classified into four main kinds. Metals, the blue part, nonmetals, the green one, metalloids, and this is the pink area, and in purple the noble gases. These are the four main types of elements in the periodic table. Let's talk first about metals. Metals are elements with less than 4 electrons in the outermost energy levels. Can you see sodium with only 1 electron in the outermost energy level? Calcium 2, aluminum 3, never exceeding 4. So less than 4, never 4 or more, always less than 4. And during chemical reactions, they tend to lose electrons and change to positive ions. Of course, when the atom will lose electrons, electrons are negatively charged. So when they will lose electrons, they will give or donate electrons, they will acquire a positive charge because protons in the nucleus will be more than the outer electrons, and we call this a positive ion. The positive ions carry a number of positive charges equal to the number of lost electrons, and because sodium will lose only 1 electron, so it will be given only 1 positive charge. That's why sodium ion acquire only 1 positive charge after being an ion. What about nonmetals? They are elements with more than 4 electrons in the outermost energy levels. Look at the chlorine. You can see 7 electrons in the outer shell. Oxygen with 6 electrons in the outer shell. Nitrogen with 5 electrons in the outer shell. During chemical reactions, they gain electrons. So count with me: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Chlorine with 17 electrons. In the outermost shell, there are 7 electrons. Now they become 8. They acquire 1 electron. They take 1 electron. Okay? Then the electrons become more than the protons. That's why it acquires a negative sign. And chloride ion carry a number of negative charge equal to the number of gained electrons. They gain 1 electron, so they acquire 1 negative charge. Metalloids, or in another word, semi-metallic elements. These pink blocks are called metalloids. Metalloids are located in the P block. And it's very difficult to know the metalloids from their outermost electrons. Now you know that metals, their outermost electrons, have less than 4, and nonmetals have more than 4. What about metalloids? We don't know. There are different number of electrons in their shells. No fixed rule. This is barium with 3 electrons in the outer level. Silicon with 4 electrons in the outer level. Now, noble gases. And as we agreed before, that noble gases are present in the last column in the periodic table. They are inert elements. They do not participate in chemical reactions with full number of electrons in their outermost energy levels. These are some examples of noble gases: helium, neon, argon, krypton, xenon, and radon. We call this group the zero group, or the group number 18 of P block. They have no electronegativity. Look at this picture. If we are transferring between elements from the left side to the right side, we will start with metals and then go to metalloids, and then the non-metals start, and at the end we reach the inert gases. In periods, each period starts with strong metal except period 1. So from period 2 till the end, it starts with a very strong metal. With increasing atomic number, the metallic property decreases until we reach the metalloid. The metalloids are semi-metals. Then, as I told you, the non-metals or the non-metallic property appears and increases till we reach the inert gases or the noble gases at group 0. Now we will discuss the graduation of metallic and non-metallic properties in the modern periodic table. If you will see in groups, the metallic property increases gradually as we go from top to the bottom, from up to down. The metallic property increases. Why? Because the atomic number and the atomic size will increase too. So it makes it easier for metals to lose electrons. Therefore, metallic property is having a directly proportional relation with the atomic number. Again, in groups, if we go from top to the bottom, from up to down, metallic property increases, atomic number increases, and atomic size increase as well. The strongest metal ever is in group 1A. Most metallic to less metallic. The strongest metal is in group 1A. And the strongest non-metal is in group 7A. So consider the corners. The left down or bottom corner, this is the strongest metal. And the up or the top right corner, this is the strongest non-metal. Now, let me show you some chemical reactions to show you the chemical properties of metals. Let's see together the reaction of metals with dilute acids. Active metals like magnesium will react with dilute hydrochloric acid and producing a salt of an acid, and the hydrogen gas will evolve as you can see here. And this is the chemical equation. Magnesium plus diluted hydrochloric acid, it will give magnesium chloride, and hydrogen gas will evolve. Now let's see this video together. Here we will see the magnesium ribbon reaction with diluted hydrochloric acid. There is a diluted hydrochloric acid in this test tube, and when we put the magnesium ribbon, what evolved? What is the result? Yes, hydrogen gas. Hydrogen gas evolved. Now we will discuss reaction of metals with oxygen. Some metals, also like magnesium, will react with oxygen, but at this time it will produce metal oxide. We call it basic oxides. Some of them will dissolve in the water, forming alkaline solution, and the alkaline solutions are known to turn litmus paper blue, of course turning red litmus paper blue. but not all metal oxides dissolve in water. Some metal oxide like copper oxide and iron oxide do not. And all alkalis are bases. They turn litmus paper blue, while not all bases are alkalis. Let's see together the chemical equation where magnesium will react with oxygen. With heat, of course, it will give magnesium oxide, a basic oxide. This basic oxide will react with the water to form an alkali solution. Let's watch this video together.
Let us try to find out if metallic oxides are acidic or basic in nature. Let us do a small experiment to see this. For this we need magnesium wire, which is a metal, water, red and blue litmus paper, a petri dish, dropper, spirit lamp, matchbox, and a pair of tongs. Light the spirit lamp first. Now hold the magnesium wire with the tongs and bring the ribbon to the flame. Observe that the magnesium burns with a bright white light. As it burns, an ash-like powdery substance is formed. This is magnesium oxide. Collect the powder in a petri dish and dissolve it in water. Take a drop of this solution and place it on the red and blue litmus papers. Observe the change in the color of the litmus papers. We observe that red litmus turns blue, while blue litmus remains the same. What does this indicate? The oxide of magnesium is basic in nature. From this, we can infer that the oxides of metals are basic in nature. When metal oxides are dissolved in water, the metal ions react with water and form hydroxide ions, which makes the solution basic. Why don't you collect some rust or some Epsom salt and try to do this experiment?
Back again to chemical properties of metals and the reaction of metals with water. Can you see this reactivity series with increased reactivity of metals while going up? So this means that sodium and potassium react with cold water and hydrogen gas evolves, and this hydrogen gas will burn with a pop sound. What about the next series? Calcium and magnesium. They react but very slowly with cold water. Next, iron and zinc. They react with steam or hot water. Steam is hot water vapor at high temperature only. The last series, silver and copper, they don't react with water at all. So that's why the reactivity increase with water in this direction. As we see the chemical properties of metals, now I will take you to the As you see the chemical properties of metals, I will let you now watch the chemical properties of non-metals. What happens if we put a piece of charcoal in hydrochloric acid? No chemical reaction, because non-metals do not react with acids. So there is a difference between metals. So there is a difference between metals and non-metals. Metals react with acids, but non-metals like carbon, they do not react with acids. So no reaction, no chemical reaction with acids. What about reaction of nonmetals with oxygen? Try to put some carbon in oxygen and burn them, heat them. They will form oxides known as acidic oxide. And these acidic oxides, when dissolve, will dissolve in water, forming acidic solution, which will turn the litmus paper red. Of course, the blue litmus paper red. This is the chemical equation. Carbon plus oxygen, when heated, it will give carbon dioxide. And carbon dioxide, when dissolved in water, it will give carbonic acid. Let's watch this video together.
Carbon is a fairly unreactive non-metal, and it's black in color. Here we have some charcoal, which is carbon, and we're going to take some in a deflagrating spoon, and we're going to plunge it, once it's started burning, into a gas jar. So we heat it over the flame of a Bunsen burner. It won't really ignite very spectacularly because it isn't very reactive, but it glows with a reddish color. And we'll plunge it into the oxygen in the gas jar, and carbon reacts with oxygen to form carbon dioxide gas. Carbon dioxide gas is colorless, but we can detect its presence by adding clear lime water, and the test for carbon dioxide is that clear lime water turns milky. So that's what we'll see. So you can see we have to wait quite a while, and even then we don't really see very much happening because carbon is really not very reactive.
Well, now time for questions. Complete the following equations. Magnesium plus diluted hydrochloric acid will give, yes, magnesium chloride and H2 or hydrogen gas will evolve. Carbon plus oxygen when heated will give carbon dioxide gas. What an oxygen will produce magnesium oxide. Magnesium metal and oxygen will produce magnesium oxide. Dear students, thank you for watching and see you later in other episodes.